Now let me add the total load on each floor. So I'll write floor, okay, floor, and I'll write dead, I'll write live, total. Okay, so we don't have any load coming from the ground floor slab, so which means that if you see the section, so this is our ground floor, this is our first floor, and this is actually our second floor, right? So ground floor, first floor, and the second floor. So this is the ground floor column. The load comes from the first floor slab and the first floor beams. Similarly, for the first floor column, the load comes from the second floor slab and the second floor beam. And also for this second floor, the load comes from the roof. This we need to remember. So the floor is ground floor. I'm calling this ground floor with reference to the columns, and second floor is the first floor, and the last floor is the second floor. So the dead load here is this is equal to, oops, sorry, not there, is equal to this, hit enter, and here also it's the same, is equal to this much value, is equal to this much of value. The live load here is on the ground floor, the load comes from the first floor slab, hit enter, or on the first floor the live load comes from the second floor, and on the second floor the load comes from the third floor. The total is this plus this, and hit enter, and if you add, so this is the total added load. And if I just auto sum these values, so this is my total load. Now what I need to do is that I need to factor it by 1.5. So that is the partial factor of safety, 1.5 as per the limit state method. So factored load now is, factored load is equal to this times 1.50, 894.2782. Okay, I also need to consider the earthquake load, so we'll take 30% extra of the factored load for earthquake considerations. So earthquake load is equal to 30% more than this load, so 1.3 times this load, hit enter, so 1162. So this is the PU, so this is the ultimate load. So ultimate load, okay, not, yeah, ultimate load is equal to this value. So this is not the earthquake load actually, so this should be 30% only, so I'll just remove this. Okay, so ultimate load is this, that is the PU, and we got the equation as PU is equal to 0.45 FCK AG minus ASC plus 0.67 FY into ASC. We will consider ASC is equal to 4% of, so 4% of AG, which means that ASC is equal to, C is equal to 0.04 into AZ, right? If we put the values in equation, so let me type the equation in the calculator. So PU is, so this value, the ultimate load is in kilonewton, so I need the value is in Newton because all other values like FCK and FI are in Newton per mm square, so I need to convert this into Newton by multiplying it with 1000 into 1000. So this is this much, so I'll just type the equation, 1162562 is equal to, okay, so 0.45 FCK is 20, 0.45 FCK times AZ. So we don't know AZ, that is our so that is our unknown, so we'll write it as X minus 0.04 times so AG, that is X, so alpha times of X, close the bracket, plus 0.67 into 500, that is Fy, times 0.04 times AG, that is alpha X. So if I just press shift and press on calc button, that is, it will do this solve. So solve for X, the value is 52747, So I think we must have two values here. So 52747 is our value. So AZ is equal to, so AZ is equal to 52767. So exact how was, so 52747.8, 52747.80. So this is the value in mm square. So if I do square root of this value, so AC and square root of answer, so the answer is 229.66 mm. L is equal to B is 229 mm, and to be on the safer side we'll take equal to 300 mm, and to be on the extra safer side you can take 350 by 350 mm column. So this 350 by 350 mm column we will use in our model. So this is how you do the preliminary design of the column. So we'll finally get L is equal to B is equal to 350 mm. And if you want to use the rectangular column, in that case you have to assume the ratio of L and B, and based on that ratio you can get the sizes using this AZ value.